In this video, I will be solving a combination problem. The translation company has 9 translators. Among the 9 translators, 3 of them only work in Spanish, 2 of them only work in Japanese, and the other 4 translators can work in both Spanish and Japanese. The company needs to select a group of 6 translators and send 3 of them to work on a Spanish project, and the other 3 to work on a Japanese project. How many different groups of translators can be selected? So, we need 6 translators, 3 on Spanish, 3 on Japanese. It's asking for how many different groups, meaning that for the 3 Spanish and 3 Japanese, they can be different. Like, for Spanish, they can be like 1 person from Spanish only, and then 2 people from the for 4 translators that can only work in both Spanish and Japanese. So basically, this is a casework problem, because each case will represent a different kind of translator. So for the first problem, for the first case, it will be 1 Spanish only and 2 both. For me, I'm just gonna do the cases that include Spanish. You can also do the cases using Japanese. So 1 Spanish and 2 both. So for the 1 Spanish, we can do 3 combination 1. And we're doing combination, not permutation here, because the order does not matter. And then 4 C2. And for those of you who don't know how to calculate combination, well, if you have n Cm, this will mean n factorial over m factorial times n minus m factorial. So this means that 3C1 will equal to 3 factorial over 1 factorial times 2 factorial, because 3 minus 1 equals to 2. So then this will equal to 3. Oh yeah, you have time for C2 also. So I'm gonna call this part out. Times 4 factorial over 2 factorial times 2 factorial, since 4 minus 2 equals to 2. This will equal to 24 over 4. It will equal to 6. So 3 times 6 equals to 18. Then this will be for Spanish. Then in this case, you'll get the Japanese. Well, we already used 2 from the both, so we still have 2 left. And 2 plus 2 equals to 4 people who can work in Japanese. It will be 4. Then we need to choose 3 from the 4. So 4C3 equals to 4. So you'll get 4 times 18 equals to 72 for this case. Then we get 2 Spanish, 2 both, and 2 Spanish and 1 both. Spanish, well, 3C2 times 4C1 equals to, well, 3C2 will equal to 3 times 4C1, well, 4C1 equals to 4, this will equal to 12. And then for Japanese, well, since we only use 1 both translator, so that means that we still have 3 more translators that can work in both languages. So 3 times 3 plus 2 equals to 5 translators that can work in Japanese. So this one will be 5 C3 equal to 120, which is 5 factorial, over 6 times 2, so equal to 10. So 12 times 10 to 120 for this case. Third case is all Spanish. So S would be 3C3. So obviously equal to 1. J No, we haven't used any both translators, so it'll be 4 plus 2 equals to 6, D3. 6 D3 will be 720 over 3 factorial times 3 factorial. So that'll be 720 over 6 times 6 equal to 20. So 1 times 20 equals to 20. For the last case, we 3 both. So for Spanish, it'll be 4C3 equal to 4. For Japanese, we only have one both translator left. 1 plus 2 equals to 3. 3C3 equals to 1. 1 times 4 equals to 4. So the total equals to 72 plus 120 plus 20 plus 4. This will equal to 216. That's how you solve this problem. Well, the key concept of this problem, it's not really a concept, but you have no combination, the formula for combination. And then when you see this kind of problem, you have to know that it's going to be involving casework. And using casework, we found the Spanish and Japanese separately, and then we multiply them together. And then for a total, you just add the 4 cases to get 216. Thank you for watching.